Good evening, everyone. I think I'm audible to everyone. Okay. Uh, so, let me introduce myself first. So, I am Chiranjeev Bhaumik. I am currently a Prime Minister Research Fellow in the School of Medical Science and Technology, IIT Kharagpur. I have described about myself in the previous week too, but maybe many speakers are new, so I am like telling about myself once more. I actually work in the field of medical AI, particularly in the field of medical image processing. I also work in computational biology and also uh, some perspective on drug protein design. So today is the week 2 of the course. Basically, we'll be studying about periodic signals to classify which signals are aperiodic, which are periodic. At the same time, we will also talk about Fourier series in general. I will also like to hear about you. It would be great if you could kindly introduce yourself. Okay, ma'am. Okay, ma'am. Okay. So, ma'am, today is the week 2. I think you have seen both the lectures, like which were actually posted in the portal. One talks about biofluid mechanics in general, and the other lecture was about Fourier series. First, the professor introduced Fourier series, giving a brief introduction of periodic signals, and then he also talked about various other types of signals like complex exponentials, and then a brief description about Fourier series and also some numericals were solved. So maybe we'll go a bit into this. We will try to understand it. We'll try to solve some questions. At the same time, we'll also look into some MATLAB visualizations. In the last week, actually, we have talked about signals and systems in general. Uh, those who have not seen the week 1 lecture, it's actually posted in YouTube. I can even post this link here. You can see if you want. Actually, I'm posting that link in the chat. Yeah. This is the link to week 1 lecture. Here, basically, as I said, we talked about signals and systems in general. We have studied about we have given some introduction about biosignals in general was given, or more particularly I talked about bioelectric signals, and also various types of bioelectric signals, for example electrocardiogram, electroencephalogram, electrooculogram, electroretinogram, electrogastrogram, galvanic skin response, etc. Then a brief description about some basic signals were given, that is the unit step and the unit impulse. After getting a visualization of those and understanding them, these signals were actually visualized in MATLAB itself. And then we talked about various types of systems in general. For example, causal system, memoryless system, linear system, time invariant system, and some simple numerical problems were solved in that part. So maybe initially let us talk about periodic signals, which actually forms the basis of the Fourier series. Then after understanding the Fourier series and or understanding periodic signals in general, we may jump into Fourier series and solve a couple of problems. Also, a simple MATLAB visualization of a complex exponential signal will also be shown. I would also like to know your feedback. If you have any problem, if you fail to understand anything, you can even mail me. You can either mail me. I will send you my email ID here in the chat itself, or at the same time you can even post your doubts in the chat box itself, or you can even speak whatever you want. It's completely up to you. Okay, so let us go to the lecture session and yeah. So after giving an introduction about myself and what we have done in course 1, let us understand what are periodic signals. We know that a signal is said to be a periodic if it has a definite pattern and it repeats itself at a regular intervals of time. So a periodic signal should repeat itself at a continuous variation or after regular interval. It means it should vary from for a continuous time it should vary from minus infinity to infinity, and it should vary with a definite pattern. So a continuous time signal, if we have, for example, we have a signal x of t, we can say that signal is periodic if and only if x of small t plus capital T is equals to x of small t, where t is actually a positive constant that represents the time period of the periodic signal, or t is also called the periodicity of the signal. So this is about periodic signal in general. Uh, a continuous time, for example, if we talk about discrete time, so the definition also follows in this similar line. So okay, let us. So I have a simple problem to, and the problem states as follows. For example, if we have a signal x of t, and x of t is equals to sine of 75 pi t. Now let us understand first whether this signal is periodic or not. So obviously it's a sinusoidal signal, so it will be a periodic signal. We know the definition, or the definition of the simple sine wave. So a sine wave x of t can be defined as sine of omega t. But omega here, if we compare both these two equations, we know that omega is equals to 75 pi. So how to find the fundamental period? So fundamental period, that is capital T, this is equals to twice pi by omega, and omega is here 75 pi. So the fundamental period is T, that is equals to 2 by 75 seconds. So this is the fundamental period for this signal. Now let us have another problem. And this problem looks quite similar to the first one, but a bit different. For example, we have a signal of this phenomenon such that x of t is equals to sine of 10 pi t into ut, where ut is actually a unit step function. And as described before, what is a unit step function? It's a function whose value vary from 0 to infinity, and it will have a constant value of 1. I will show the MATLAB visualization of unit step. It will be more clear. But we know what is a unit step function. So unit step function, the value will lie from plus, that is 0 to plus infinity, and it will have a constant value of 1. But the value will be 0 from minus infinity to 0. So if we multiply a step, that is a unit step function, with a sinusoidal function, what will we get? We will get a sinusoid which will vary from 0 to infinity. But from minus infinity to 0, the value for this signal x of t will be 0, because multiplication of 0 with anything is obviously 0. So we see that this signal only extends from 0 to infinity, but from minus infinity to 0, the amplitude value is 0. So we say that this signal is aperiodic. Okay. After solving this two problem, one question may come to your mind. Okay, it's clear. that I have two periodic signals, that is periodic signal, let us consider x1t, and we have another periodic signal x2t. Now, is it true that sum of two periodic signals is always periodic, or it is always aperiodic? So then let's look into this. Let's consider another problem. See, where x of t is equals to sine of twice pi t plus cos of root 2 pi t. Okay. So here omega 1 is equals to 2 pi and omega 2 is equals to root 2 pi. See, sum of two periodic signals are only periodic when the ratio between their period is a rational number. Okay, that is important. So we have omega 1 by omega 2, that is 2 pi by root 2 pi. So we have equals to root 2. And we all know that root 2 is an irrational number, because the definition of rational number is that a number or a ratio is said to be a rational number if it is of the form p by q, where q not equals to 0 and both p and q belong to integers. And we know root 2 is not an integer value, isn't it? The value of root 2 is almost 1.4142. So this is a aperiodic signal. So let us have another question, and here it is x1t is equals to sine 3t plus sine pi t. Here omega 1 is equals to 3. If we compare with the basic, that is the fundamental sinusoidal signal, that is sine xt, let us consider a signal xt is equals to sine of omega t, and if we compare sine of omega t with sine of 3t, we have omega 1 is equals to 3. Similarly, we have sine of pi t. If we compare with the basic fundamental equation, that is we have omega 2 is equals to pi. So we have omega 1 by omega 2 is equals to 3 by pi. So obviously 3 by pi is not a rational number as goes by the definition, because pi is not rational. So we will say that this is aperiodic signal. So this x1t is a aperiodic signal. So let us consider another problem. So here x of t is equals to sine of 4 pi t plus sine of 7 pi t. Similarly, if we compare with the basic equation of sine of omega t, we have omega 1 is equals to 4 pi and omega 2 is equals to 7 pi. So t1 is equals to twice pi by omega, and we have time period t1 is equals to 1 by 2. And similarly, we have t2 is equals to twice pi by 7 pi, so that's equals to 2 by 7. So the ratio t1 by t2 is equals to 7. So obviously it's a rational number and hence it's a periodic signal. Okay. So now, for example, instead of two signals, instead of summation of two periodic, let us have summation of three signals. That is, here xt is equals to cos 60. Let us consider cos 60 is equals to x1t, sine 8t, which is equals to x2t, and e to the power I2t, which is equals to x3t. So let us consider xt is equals to x1t plus x2t plus x3t. Similarly, if we compare with the fundamental sine and cos equation for x1t, that is for cos 60, we have omega 1 is equals to 6. Similarly, for sine 8t, we have omega 2 is equals to 8. And for e to the power I to t, we have omega 3 is equals to 2t, because e to the power I to t can be, we know the general form, it is I to the power I to t can be written as in the general form as e to the power I omega t. So omega is 2 here. Now t1 is equals to the time period for x1t is equals to twice pi by 6, that is equals to pi by 3, and t2 is equals to twice pi by 8, so this is equals to pi by 4. Sorry, it will be pi by 4, and t3 is equals to twice pi by 2, which is equals to pi. So t1 by t2 is equals to 4 by 3, which is actually a rational number. But but T1 by T3 is equals to, uh, my mistake, T1 by T3 is equals to 1 by 3. Okay, so this is also a periodic signal. It's not aperiodic, it's a periodic signal because these are all rational numbers. So this is another problem. This is an assignment problem for you all. This is, let us consider a signal x of t, which is equals to cos t plus sin pi t. Okay, cos t plus sin pi t. Now if we consider, let me give you a hint. If we consider and compare this cos t equation with cos of omega t, that's the fundamental equation. We have omega 1 is equals to 1 here for this cos t, and t, this time period, will be equal to twice pi by omega, that is twice pi. Similarly, for sin pi t, we have time period t2, which is equals to twice pi by omega, and omega is pi for the signal sin pi t. So t1 is equals to pi, and t2 is equals to, that is t2 is equals to twice pi by omega, and omega is equals to, t1 is equals to uh, a rational number, and t2 is equals to rational number. T sorry T1 is equals to a rational unrational, T1 is equals to pi, and T2 will be not equal to a rational number. So if we get the ratio, if we take the ratio of T1 by T2, we will get a irrational number. So this signal will be aperiodic. I would like you to solve this problem. Okay, this is an assignment problem for you. Now let us look into a MATLAB visualization for a complex exponential function. Okay. Complex exponential function. Before looking into the MATLAB visualization for a complex exponential function, as I have talked about the unit step, and maybe you are interested in understanding or seeing unit step function, let us study this first. Then we will go to the visualization for the complex exponential function. Okay, so what is a unit step function? A unit step function is a unit step function is a function where the value will be constant, or the value will be 1 for 0 to infinity, and the value will be 0 from minus infinity till 0. Okay, so this is a custom function that is written in MATLAB, because MATLAB, to the best of my knowledge, doesn't have a inbuilt unit step function. So the function is this. So the function will take three variables, that is a, b, c. So a, b is actually the range, a is the starting range, b is the ending range, and c is actually the shift in the signal. For example, in through this function we can plot unit step function, the general unit step function, and also you can plot a shifted unit step function. Okay, if c is 0, then we'll get the original unit step. Otherwise, we can change the values accordingly to our need. So we have a function comma y, a function of y comma n, which is equals to unit step of a comma b comma c. So what is n? N is equals to a to b. So n will have values in from the entire range. For example, if we consider, if we want the example problem as such, where un is equals to, so where you want to plot un from minus 5 to 5, so here a is equals to minus 5 and b is equals to plus 5. And if we want to plot the un that's not the shifted one, will have c is equals to 0. So this is the function. So this function, what we will plot zeros from minus 5 to 0 and 1 from 0 to 5. If we want this function and place these parameters. So let us play. For example, if we want to use this previous function, there is a unit step, and we want to plot unit step from, let us consider I want to plot unit step from minus 15 to plus 15. Okay, we want to plot the value of unit step from minus 15 to plus 15. And as we want to plot a original unit step function, we don't want a shifted one. So here c will be equal to 0. Okay, so this is the function, and we all know the difference between stem and plot. Stem will give discrete points, where plot will give continuous points. So let me plot this uh, function. Let run this code. Okay, so this is clear. So we wanted a unit step from minus 10 to 10, where the value should be 0 from minus 10 to 0, and the value will be 1 from 0 to 10. And as we have written stem, so we are getting discrete values. Okay. Now for instance, you don't want to plot discrete values. So what you do, just replace the command stem with plot. Okay, and then let's run the code. Okay. Now, for example, we want to plot the value of unit step, but not the original one, but shifted one. Okay, so this is the thing that we want. Okay, but we want a shifted value. So what we do is, let us consider we want to plot un minus 7 and ranging from minus 20 to plus 20. So this is the graph which we want to plot. That's a shifted unit step. So here a is equals to minus 20 and b is equals to plus 20, and as we want to plot u of n minus 7 means we want to plot a graph of this function where the value will be 1 from 7, that is from plus 7 to infinity, and the value will be 0 from minus infinity to plus 7. So the third variable, that is c, will be 7 here. Okay, and these are the, and obviously we want discrete points, so we write stem and then we write the variable name, that is we write x label as time, y label as amplitude, and obviously we want grids to be on in the graph for the for better visualization purpose. Okay, so let's plot this curve. So it's clear the value is 1 from 7 and after, and the value is 0 from minus 20 to 7. Here it is minus 20 till plus 20 because this is the range that we are setting. We can set our range to whatever we want. Okay. So this is the unit step. I think it's clear, and then I think the problem that we have stated before to understand whether that signal was periodic or not, and that is also quite clear and evident. Okay, so we can write various commands to make our graphs look beautiful. That obviously depend on the user and what he or she wants. So let us talk about, or let us see a visualization of complex exponential function. For example, we have a function of this manner. Okay, we want an exponent function, which is actually in this manner. We have x of t is equals to e to the power of 1 plus 0.3i into n. Okay, so x of n is equals to exponent of 1 plus 0.3 of I means the imaginary, the iota, into n. And the range of n, that is the range of this function, will lie from minus 3 to plus 3. So this is the range of the function that we want. Okay, so this is the range of the function we want. Now what we want to do is we want to plot this function. So we want to plot this function. So what you do is just run this command. Okay. So we can see from -3 to +3, this is actually an exponential function. If we see properly, see e to the power, it is of the form of e to the power st, where s is nothing but sigma plus j omega. And sigma is a real part, where for this case, sigma is equals to 1 and omega is equal to zero point 0.3 here. So this is actually, this function can be actually written in this manner. If we consider, for example, we have a function e to the power st. So obviously s is here 1 plus 0.3j, and obviously t is equals to n. It's clear. So what we do, this function can be actually written in this manner. E to the power st can be written as e to the power sigma plus j omega t, and e to the power sigma plus j omega t can be written as e to the power sigma of t into e to the power j omega t. And we all know e to the power j omega t can be written in the form as, we all know e to the power j theta can be written as cos theta plus j sin theta. So here this function can be written as e to the power sigma of t into cos of omega t plus j sin omega t. So e to the power sigma t is just the envelope, and the e to the power j omega t, or in other words cos omega t plus j sin omega t, is actually the exponential function. Okay, so this is clear. So if you want to further improve the visualization, so what we do, we can use x label, y label. We can use, if we want to plot multiple functions, if for example if you want to plot for example we have a different exponential function, we can use functions like subplots and plot it all together. So for example, I want to mm, do an x label, x label is, what is x label? It's time. And what is y label? Control C. And what is y label? Y label is amplitude, ampli amplitude. Okay, and let us also make great better visualization purpose and run this code. So this is the thing we have. For example, you have another function, and the function is a bit different. And the function, let us define another function. That is, let I have another function, that is x2, and x2 is exponent of, let the real part be different. Let the real part be 4 plus j into zero point 0.5 j into 0.5 into n. So this is, let me have another function. So what you do, I want to plot this function. So if we want to plot both the graphs parallelly, we have to use subplot. So subplot 1 to 1. Fine. Now we want to C, control V, subplot n comma Okay, so this is clear. Now let me plot this graph. Okay, if you want, let's plot this graph. Okay, so this is how the graph looks. We can on the grid to look better. Okay, and obviously accordingly you can label the graph. See. This is how this is for the labeling purpose. Okay, see, we can actually plot our own function in MATLAB. MATLAB has given a wide range of functions and implications. So and many things can be done in MATLAB. We can write our own custom function and do various processing. Okay, so this we have looked into complex exponential. So the next topic that we'll be looking today. Yes. So the next topic that we'll be looking today is actually Fourier series. So, so what is Fourier series? See, before understanding Fourier series, we all know why we have studied periodic signals because it is widely useful for analyzing periodic signals, and Fourier series works for periodic signals only. So Fourier series, what does it do? It actually converts a periodic signals in terms of infinite sum of sines and cosines. And obviously it is useful for analyzing periodic signals only. So okay. So a Fourier series is an approximate technique. It's actually a technique which can convert any non-sinusoidal signal to that all periodic signals can be represented in unique form. Okay. So there are various conditions for Fourier series. So in the next class, we will be talking about Fourier transform most probably, and there we will be talking about various conditions of Fourier transform, various properties. At the same time, we'll be solving a couple of numerical problems on Fourier transform. So this is then before talking about Fourier series and solving a problem. So I would like to know that the the people who are present here, have they finished watching the week 2 lectures? Ma'am, so ma'am, is the week, what's the last date for the week 2 assignment to complete that? Okay, it's 10th. It's 10th. 10th is the last date for both the assignments, isn't it? For week 1 and week 2 both. Okay, okay. No, you can even speak. There is no problem. It's not that we have like you can write. So okay, this is I got it. So if you have any couple of, for example, I cannot solve the assignment problems directly in the class, but as I think, but if you have any doubt, you can tell me. I can even share my email ID with you. This is my email ID. It's better like you give me your email ID, I'll share it there. Is it possible? I'll send a mail there. So, in case of any doubts or in case of any problems, if you face any problems in the assignment part, you can always come to me. It's not a problem. And obviously, we'll be meeting in the next class. So, okay, ma'am, I got your email ID. I'll note it down. Okay. So there, in case of any doubt, I can share the. You can share your problems. We can discuss those problems in the next class. And it's always wise. It's always good to. It will be always good and helpful for me also, and obviously for you all, if you can watch the lectures before we come to the live session, because it will be very helpful. Maybe you will be able to ask the doubts that were not clear. If it is not clear in the class, we can discuss it once more, and in this way, if uh, if most of you have those doubts, I can even prepare a lecture or some numericals based on the same topic in the next week. Okay. So, ma'am, everyone, I would kindly request to please look into those lectures before we attend the live session. It's very helpful for everyone. Okay, it will be helpful. Yes, ma'am, isn't it? Ma'am Bharat Shri Jai Bharati. Uh, yes, ma'am. I understand what you said. Answer for assignment problem. If you could kindly elaborate. Hello, ma'am. Jai Bharati. Yeah, good evening. You just solve it. X of t is equals to cos t plus sin pi t. Tell me in the next class whether it's periodic or not. Like, if you have any problem. Yes. If you could introduce yourself, like you are a student, isn't it? Yeah. Okay. Tell me about you. Okay. So you are doing your BTech in electronics. So it's a BTech is a 4 years course. Okay. Okay. In medical electronics. Okay. 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 Fine. Have you done assignment number one? Okay. So was it clear? Like, was it okay? Yeah. What about a week two? Okay, 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 fine. So, in case of any problem, I will get back to you all. You tell me, or if you have if you have any concept which is not clear, you can always write it here or obviously mail. Then maybe we can discuss that concept in the week three lecture also. Obviously, I will the major chunk or major focus of week three will be the things which were done in the week three itself, but this can also be done. Okay. So fine, let us go into Fourier series. Let us talk about Fourier series. So this is we have understood what a Fourier series do. We understood that Fourier series exists for periodic signals. We know that Fourier series actually reduces a signal to infinite sum of sines or cosines. So this is the next thing that we have is the condition for Fourier series. Condition for existence of Fourier series expansion. So the first condition is that the signal should have finite number of maxima and minima over its time period. I think you are clear. I think you all understood what is the meaning of maxima and minima. So the next thing is the signal should have finite number of discontinuity. The signal should not be a constant one, it should have finite number of discontinuity over time. And the next thing, the signal should be absolutely integrable over its time period. Okay. So this is the actually condition for Fourier series. So in the similar manner, in the same line, we will have the condition for Fourier transform. We will discuss it in the next class. So let me have a very simple problem. Let us consider that I have a signal of this form where x of n is equals to 1 plus sine of twice pi by 10 into n plus cos of n pi 4 pi by 10 plus pi by 4. Okay. So obviously 1 is a DC term, so DC term doesn't do anything, it just shifts the signal. For example, it will just shift your signal to a particular range. So the periodicity or the time period of sine twice pi by n, that is equals to 10. How is it? So if we compare the fundamental signal of sine of omega n, we have omega is equals to twice pi by n, and time period as discussed before, this is equals to twice pi by omega. So if you do twice pi by omega, you will get t is equals to 10. So this the time period is 10. And similarly, if we do for this, if we check the second function, this cos of n pi 4 pi by 10 plus pi by 4, it is of the form of cos of omega n plus phi. Phi is a phase shift and phi is equals to pi by 4. But omega is obviously 4 pi by n here, 4 pi by 10 here. So the time period for this signal, it is equals to twice pi by omega. So twice pi by 4 pi by 10. So what will be the time period? So if we find out T2, that is twice pi divided by 4 pi divided by 10, you get 5. I would request you to kindly solve it by your own. I don't think it's a problem. It's a very easy problem. I would just like to solve it. I don't know. I just written the answer there. So we have T1 is equals to 10, T2 is equals to 5, and obviously T1 by T2 will be a rational number. So obviously the signal is a periodic signal, and we know it's a periodic signal. We can write the signal, we can write this in the form of a Fourier series. And another thing, we also know that e to the power of j theta, that is e to the power of j theta is equals to actually cos of theta plus j of sine theta. And sine of theta, like we can write, for example, we can write cos theta. For example, if we already know, I'm just telling you something. If you are not clear, you can say it to me again. We know that e to the power I theta is equals to cos theta plus I of sine theta. Okay. Now, if I write sine theta in terms of e to the power I theta, I know everyone has done this kind of derivations or simple manipulations, but just I'm saying. So we can write cos theta in terms of e to the power I theta as cos theta is equals to 1 by 2 e to the power I theta plus e to the power of minus I theta. And cos theta cos theta is this, and sine theta, it is equals to 1 by 2j into e to the power of j theta minus e to the power of minus j theta. I think it's clear. You can try this simple manipulations in your copy, and if you face any problem, you can tell me. So, what I said, sine theta can be written in terms of complex exponential as 1 by 2j e to the power of j theta minus e to the power of minus j theta. And cos theta can be written as 1 by 2 into e to the power of j theta plus e to the power of minus j theta. So fine. So x of n. Now let us convert sine theta in terms of complex exponential and cos theta in terms of complex exponential, and write as sine of twice pi by 10 into n can be written as 1 by 2j e to the power of j theta, and here j theta is twice pi by 10 into n minus 1 by 2j e to the power of minus j twice pi by 10 into n. So this is sine theta has been written in this exponential part. Similarly, we can write cos of theta as 1 by 2 e to the power j pi by 4 into e to the power j 4 by 4 pi by 10 into n plus e to the power of plus 1 by 2 e to the power of minus j pi by 4 into e to the power j 4 pi by 10 into n. So this can be written in this manner. And obviously the Fourier coefficients, that is a1, it is equals to 1 by 2j, and phi of minus, so that is phi of minus 1 is equals to minus 2j, phi of 2 is equals to 1 by 2 into e to the power j pi by 4, and similarly you can find a of minus 2. These are actually the Fourier series coefficients that we have found out. I actually, this will be more clear if you check the theory lecture, then you can go deep into this numerical. I would like you to kindly note this problem and solve it in your copy. In case of any doubts, we will talk in week number 3, or you can even talk now. If you have seen the lecture, it will not be a problem, and otherwise you can talk in week number 3 for further clarifications. Okay. So this is the thing. This is what I actually thought of doing in week number 2. I would like you to, as I said, I would like you to see this video lecture for week number 2, the 2 lectures. One is on fluid mechanics, or more particularly fluid flow in blood or the trachea, that has been talked about, and also the next is about Fourier series, about periodic signals in general. So I would like you to see these lectures, solve the numerical problems, the assignment problem. The assignment problem for week 2 is actually pretty easy and straightforward. There are some concepts of week 1 which has been, where some question has been given there. Like for example, you can see a question on a unit step, and various questions are there. It's easy. I think you can look into it, solve those, and in case of any doubt, we can talk about it in the next class. Okay? Okay, ma'am. Okay. Okay, then I think we can. If you have any doubt, then you can ask me. Otherwise, we can close the session. Okay. Okay, I think we can close the session. Thank you.